11. Four tanks contain water to the depth shown, as the bottom of which tank is pressure due to the water greatest. Pressure equals rho g h. So it depends on rho g and h. Rho, they have the same density, all of them water. G is constant, so pressure here depends on the height. The height here, we have the maximum height at A. A gas heated in a sealed container. The volume of the container does not change. What happened to the particles of the gas? So we have a sealed containers. There are gas inside, and there is a thermal energy supply. The volume does not contain. What happened to the particles? The average distance between particles increases. We can't say this because the volume is constant, so we can't say this. The average kinetic energy of particle increases. Yeah, thermal energy increases, so the particles' kinetic energy also increases, so the speed increases. The mass of each particle increases. It's totally wrong. The volume of each particle is also wrong, so the answer is B. Question 13. Air in a sealed syringe is slowly compressed by moving with the piston. The temperature of the air stays the same. So we have the volume decreases. The relationship between pressure and volume is inversely proportional. When the volume decreases, pressure increases. So the pressure of the air decreases. This is wrong. Because of the particle now move more slowly. The particles move with the same speed because the temperature is constant. All this is correct. The pressure of the air decreases. Now the pressure increases. Because of the air of syringe was now smaller. It's correct, now smaller, but the pressure increases, does not decrease. The pressure of the air increases because the particles now hit the syringe walls more frequently. Yes, correct, because the volume decreases. The pressure of the air increases because its particles now travel more quickly. Is also wrong because the temperature is constant, so the speed is constant, not more slowly or more quickly. So the right answer is C. Question 14. Which statement about the evaporation of a liquid is correct? The least energetic particles escape from the surface. Wrong. The most energetic particles escape from the surface and temperature of liquid decreases. So the least energetic particles also escape. So it's wrong. The most energetic particles escape from the surface and the temperature of the liquid decreases, not increases. So the answer is C. A solid is heated, causing it to expand. Which effect does this have on the mass and on its density? The mass does not change. The mass stays the same. The number of particles stays the same, so no change in mass. The density, what's going to happen to the density? Rho equals m over v. M is constant, so the relationship between rho and v is inversely proportional. As the volume increases, so density decreases. Density decreases. A glass test tube containing a water is heated at the top. The water at the top boils, but the water at the bottom remains cold. Which row explains why the water at the bottom of the test tube remains cold? So when heat, we apply heat here, so this part of water becomes hot, and this in the bottom here is still cold. For glass, what do you expect about glass? Good or poor? As the heat does not move through glass here from the top to the bottom, so we can consider glass is a poor thermal conductor. For the same idea of water, water does not transfer energy well. Okay, so it is also poor thermal conductor. Question 17. A vertical stick is dipped up and down in water at P. In 2 seconds, three waves crystals spread out on the surface of the water. Which statement is correct? Distance x, the amplitude of the wave. Distance x represents the distance between two wave fronts, which represents the wavelength, not the amplitude. Distance y is the wavelength of the waves. Distance y represents two wavelengths, not the wavelengths. Each circle represents a wavefront. Each circle represents a wavefront. This is correct. The frequency of the wave 3 Hz. The frequency here equal total number of waves divided by time. So we have 3 waves divided by time 2 seconds, which equals 1.5, not 3 Hz. So the answer is C. Seismic wave from the epicenter of an earthquake takes 100 seconds to reach the point 300 kilometers away. When they arrive, they cause the ground to vibrate with a frequency 2 Hz. What's the wavelength of these seismic waves? We want wavelengths. Wavelengths equal V over F. We have V. We don't have V. We have, but we can find F. V speed over the frequency. We have the frequency is 2, so we need to calculate V. V is distance over time. Distance 300 kilometers. Kilometer. We need to convert it, but the answer here in kilometers, so we will not convert. 300 kilometer over time 100 second gives you about 3 kilometer per second. V here 3 kilometer per second and F is 2. So the answer is 1.5 kilometer. Which diagram illustrates diffraction of two waves? So we have less diffraction, which makes this curve. This one is correct. For this one, we see here, this is a refraction. The wavelength changes. Figure B represents refraction. Figure C represents reflection. Figure D also represents refraction. So the answer is the correct one, which represents diffraction, is A. Remember, diffractions happens on gaps or edges. Question 20. A single ray of light is reflected by two mirrors. The diagram shows the ray of light incident on mirror 1. What is the angle of refraction in mirror 2? We'll complete the diagram with the same angle. We'll draw here a normal. Then we'll draw the angle of refraction. Angle of refraction is 50. So the other angle here is 40. For this angle is 60. So the complementary angle is 120. So we have 120, 100. We have 40 here. Both of them equal 160. So minus 180. So the angle here is 20. So make sure the angle here is 70. So the angle of reflection also 70. So the answer is C.